In this video, I'm going to be explaining how to find derivatives of inverse trig functions. There are two ways that an inverse trig function may look. It could either be using a -1 above the trig name, or we could use arc to symbolize an inverse. So be able to recognize them in either form using that -1 or arc. There are some basic formulas for our derivatives. In every case, the input is being symbolized as u. So when we find the derivatives, we're going to find the derivative of that input divided by some form or expression down here. And we're plugging in that input for the u spots. So these are the 6 forms of the basic inverse trig functions. And it's just best to memorize them. Let's practice using them. So if we have a function described as the inverse of sine of x, then what's its derivative? Well, I'm going to say that u is that input variable x, and then I'm going to substitute that into our derivative form, which is the derivative of the input divided by the square root of the quantity 1 minus that input squared. So the derivative of x is 1, and if I plug x into the u spot down here, I have the square root of the quantity 1 minus x squared. And we could just leave it in that form and be done. Let's do another one, this time with tangent. So if we have a function that is the inverse of tangent of the input 1/2 x, then what's the derivative of that function? So I'm going to substitute that input in place of u. So u is going to be 1/2 x. And then the derivative of the inverse tangent looks like this. Derivative of the input divided by the quantity 1 plus the input squared. So the derivative of 1/2 x is 1/2. If I plug 1/2 x into that u down there, I get 1 plus the quantity 1/2 x all squared. So when we simplify, if I square 1/2 x, that's 1/2 times 1/2, which is 1/4, and x times x, which is x squared. And then if I divide, that means I'm going to multiply by the reciprocal, or multiply by the 1 over the denominator. So 1/2 times 1 over the quantity 1 plus 1/4 x squared. I'm going to distribute my 2 to everything downstairs. On top is just 1 times 1, but on the bottom I got to distribute that 2. So 2 times 1 is 2, plus 2 times 1/4 x squared. 2 times 1/4 is 2/4, or 1/2 x squared. And we could leave it like that and be done. Here's another example, this time using arc instead of that -1. So this is the inverse of cosine of -2x cubed. So I'm going to say that my input, -2x cubed, is in place of u. And the derivative form of the inverse, or arc cosine, is the opposite of the derivative of the input divided by the square root of the quantity 1 minus the input squared. So be careful with that opposite or negative symbol right there. If I find the derivative of my input, I get -6x squared, but I want the opposite of that. So I'm going to take the opposite, make it positive, and write 6x squared on top. On the bottom, if I substitute that input into the u spot, then I'm squaring -2x cubed. If I square -2, I get +4. If I square x cubed, I get x to the 6th. So I have 1 minus 4x to the 6th. And we could call it done. Here's a little bit of a challenge exercise. Let's put a bunch of rules together here when we differentiate this function, the inverse or arc sine of x plus x times the square root of the quantity 1 minus x squared. So I got to differentiate each of these terms individually. That's that sum and difference rule. So if I find the derivative of the inverse or arc sine, that would be the derivative of the input, so 1, divided by the quantity or the square root of the quantity 1 minus the input squared. So 1 minus x squared under the radical on the bottom. Let's move on to the next term, plus the square root of x times the quantity, or the square root of the quantity 1 minus x squared. So here we have a product rule happening. When I find the derivative of this term, I got to break it up into my product rule. So the derivative of the first term times the second term plus the first term times the derivative of the second term. So the derivative of x is just 1. And then rewrite that second function. I just changed that square root symbol to an exponent of 1/2. So we got plus the first function times the derivative of the second function left over. So we're adding x, keep that, and find the derivative of this. We got to use the chain rule to find the derivative of this function. So I'm going to drop that exponent to the front and subtract 1 from my exponent, keep the inside the same, and then multiply by the derivative of the inside. So the derivative of negative x squared is negative 2x. Derivative of 1 is 0, so we ignore that. So now we just got to simplify this big, long expression here. So what I did is I took negative 2x times x, that's negative 2x squared, and then multiply that by 1/2, so you get negative x squared. And then we have this raised to a negative exponent, so I'm going to drop it down to the bottom. So all of this on the end here simplifies to negative x squared over the square root of the quantity 1 minus x squared. I did 1 times this quantity, that just left itself there, and I just rewrote the first quantity using an exponent of 1/2 rather than a radical sign or a square root. So now we have to try and simplify all of this. I think the easiest way is to look at things that have the same denominator. So the first and last term we can combine because they have the same denominator and just rewrite it as one fraction. So 1 minus x squared all over the denominator. And then we're trying to add this term over here. Well, before we do that, let's simplify this. So this is 1 minus x squared all raised to the first power. And then we have the same quantity down here raised to the 1/2 power. So if I have two expressions being divided, I subtract their exponents. So 1 minus 1/2 is 1/2. And so I'm left with that quantity raised to the 1/2 power, or the square root of that quantity. And then if I add it to another one of the same thing, then I have 2 of them. So our final answer is 2 times the square root of the quantity 1 minus x squared. So you could write it using a 1/2 exponent or a radical sign or a square root sign. Either way is good. Lots of different ways to simplify this, to go from this step to get to the final answer. Some ways are easier than others. I found this to be the easiest way. So there we go. That's derivatives of inverse functions. It's just a matter of knowing your derivative forms and being able to use them.